we're in the middle of section 4.2 of Rosen, and I want to derive a couple of expressions for binary integer addition before we look at the slides. So I'm going to write down two binary numbers with 3 digits each. I'm just going to use A's to represent the values of the digits. So A2, A1, and A0 is a 3-digit binary integer. And I'm going to write another one with B2, B1, and B0. And of course, these would, each of the digits would have only a value of 0 or 1. And I'm going to add them up just like we would add up regular uh, decimal numbers. And when I add A0 and B0, I write down what's called the sum bit or the sum digit to get S0, and I get a carry bit or carry digit called C0. And because that C0 is associated with the 0 column, I'm going to erase that and make it a little bit nicer. Okay, and then when I add up, and I have an implied carry value of 0 for the first column. When I add up the column of numbers to get the next one, I'm going to get a sum bit called S1 and a carry bit called C1. And then on the third column, I'll add C1, A2, and B2 to get the sum bit for the third column, and I get a carry digit for the third column. And since these were 3-digit numbers, the carry digit for the last column shows up over the fourth column, and it just gets written down directly. And that's typical for decimal addition as well. All right, so let's talk about how we can formulate this into code, and we'll look at a pseudocode example in just a second. And we're just going to use it in general indices. Well, I have a AI plus BI plus CI minus 1 will be in the ith column that we add up. And I want to get a number that'll be a 2-digit number that's represented as CI SI base 2. And I can expand that out using properties we'd seen earlier in this section to be 2 times CI plus SI, since that is the 2 to the 0 digit and that is the 2 to the 1 digit. And that equals AI plus BI plus CI minus 1. So I want to be able to solve for SI and CI. Let's do SI first. So SI is just going to be A sub I plus B sub I plus C sub I minus 1 minus 2 times CI. And that's straightforward enough, except when I start in a column, I know AI, BI, and CI minus 1, but I don't know CI. So actually, I need to calculate CI first. So we'll come back to this equation in just a minute. Calculate CI before SI. Well, what is CI equal to? CI is equal to 1 when 2 or 3 of AI, SI, oops, that'll be BI. AI, BI, and CI minus 1 equal 1. And CI is going to be equal to 0 when 0 or 1 of AI, bi ci minus 1 equals 1. So I need a function that will map the values of ai, bi, and ci minus 1 to 1 when 2 or 3 of them are 1, and to 0 when only 0 or 1 of them is 1. So I'll just write down ai plus bi plus ci minus 1. And if that sum is 2 or 3, the way I can make that to a B1 is by dividing it by 2 and taking the for function. And that also works for the other case. So when ai plus bi plus ci minus 1 is 1 or 0, if I divide by 2 and take the for function, I also get 0. So this becomes our expression for the carry bit, and then we can use it to calculate the sum bit. And now we'll go look